Hi everyone, so here we're going to start with numerical solutions for chapter 3 energy. So we are going to see the numerical based on factor affecting work done. Means these numericals are based on the formula of work done. So as we already know that there are two factors which affects work done is force and displacement. Then to calculate the total amount of work done, we use the formula work done is equal to force into displacement. And here we have the formula for the work done. So work done is equal to force into displacement, or it can be also written as W is equal to F into D. Next, what is the unit for the work done? So unit of work done is joule. Now we are going to see the numericals. So here we have the first numerical. Calculate the amount of work done when a force of 30 Newton displaces a body through 25 meter in its own direction. So in this numerical, force is given which is 30 Newton, and when the force is applied, it displaces that body to 25 meter. Then we have to find out its direction. So to find out the direction, we are going to use the formula again. Work done is equal to force into displacement. So force is given here as 30 Newton, displacement is given as 25 meter. So work done is equal to 750 joule. Now we are going to see the next numerical. So in the next numerical, a work done of 40 joule is done when a force of 15 Newton is applied to a cart. So this numerical states here that a work done of 40, so when a force of 50 Newton is applied on a cart, it has done a work of 450 joule. Then you have to find out the distance. So now in this numerical, work done is given and force is given, and then again we know the formula work done is equal to force into displacement, or displacement is equal to work done by force. So therefore displacement is equal to 450 divided by 15, and then we will get displacement as 30 meter. Then in the next numerical we are going to see, so a work done of 15 joule is done in moving a body through a 2 meter in the direction of applied force, and calculate the magnitude of force. So in this numerical we are going to find out the force when the work done is given and displacement is given. So again we are going to use the same formula, work done is equal to force into displacement. So force is equal to work done by displacement. So already it is given work done is equal to 15, displacement is equal to 2, so the force is equal to 7.5 Newton. And then next, so numerical number 4, a force of 50 Newton causes a displacement of 5 meter in its own direction. What is the magnitude of work done? So in this numerical, what is given? Force is given, displacement is given, and we have to find out the work done. So work done, we already know its formula, work done is equal to force into displacement. So work done is equal to 15 into 5, and then we'll get the answer work done is equal to 75 joule. And then the next numerical, a boy does a work of 1000 joule in dragging a sack of rice through a distance of 20 meter. What is the magnitude of force applied by the boy? So in this numerical, we have to find out force. So work done is given, displacement is given. Again we are going to use the formula work done is equal to force into displacement. So therefore work done is equal to or force is equal to work done by displacement. So as work done is given 1000, displacement is 20 meter, so force is equal to 1000 by 20, which is 50 Newton. So next, question number 6. So a girl applied a force of 80 Newton in pushing a table such that work done by her is 15 Joule. Calculate the displacement produced in the table. So in this numerical, force is applied, means force is given 80 Newton, and work done by her on the table is given as 15 Joule, and we have to find out the displacement. So again we are going to use the same formula, work done is equal to force into displacement. So displacement is equal to work done by force, and then we are going to divide 15 by 80, and we are going to get the displacement as 0.18 meter. So next, question number 7. An energy of 4 kilojoule causes movement of a body through 64 meter in the direction of force. Calculate the force acting on the body. So here this numerical states that total energy applied on an object is 4 kilojoule, and when the 4 kilojoule energy is applied, it causes a movement on the body through 64 meter in the direction of force. Then we have to calculate the force acting on the body, means that energy is given and it causes a displacement of 64 meters, so displacement is given and we have to find out the force. So as we all know that energy applied on an object is equal to work done on the object. So therefore work done is equal to 4 kilojoule. So we have to convert this 4 kilojoule into joule. So we are going to use the formula 1 kilojoule is equal to 1000 joule. So therefore 4 kilojoule is equal to 4 into 1000, which is equal to 4000 joule, and then displacement is given 64 meter. So therefore work done is equal to force into displacement. We have to calculate force, so force is equal to work done by displacement. So then we will divide 4000 by 64, and we will get the answer for the force is equal to 62.5 Newton. So here we have seen all the numericals related to work done, and we have used the formula work done is equal to force into displacement, or force is equal to work done by displacement, or displacement is equal to work done by force. Thank you.